Hello guys, welcome to recitation number 17. So I'm going to share this recitation right now, so we go through it immediately. So the first problem we have here says two identical cellos play two different notes while tuning to the highest string. The first plays a note with a frequency of 220 hertz. You hear beats separated by 2 seconds. So this is the trick. So the number of beats per second is what you add or subtract from the frequency. Is that okay? To know the other frequency that is superimposed, kind of that makes the interference of the sound that you hear from the note. So which of the following could be the frequency of the note played by the other cello? So the other cello, we don't know, but we know the first cello at 220, and we know the number of beats per second. So you hear beats separated by 2 seconds. So it means you hear 1 beat every 2 seconds. So the number of beats per second becomes 1 divided by 2. That is half. So the other frequency must be the frequency of the first cello plus this number of beats per second or minus this number of beats per second. Two possible answers. So it's going to be 220 plus half or 220 minus half. That's how you get that. But in this case, we only have 220.5. So the other correct answer would have been 119.5, but it's not the option. So the only correct option here is D, 220.5. So you just add or subtract the number of beats per second to whichever frequency you have to get the other frequency. Then the second question, this is question 02, not 01. The second question says, A in a pipe forms longitudinal wave patterns represented by diagram. So this is just a pipe closed at one end. This is a very standard case. You can read this in your textbook. And the general formula is this one, the B, the second one, NV over 4L, N equals 1, 3, 5. So I'm just proving it right here. So for A, for this part A, the length of the pipe is just 1/4 of a wavelength. So if you complete this wavelength, it's going to be up to here. That's one wavelength. So for A, it's 1/4. So L is lambda over 4. Lambda is 4L. I put that in my frequency formula. V over lambda becomes V over 4L for the frequency of A. For frequency of B, so here the wave must always be open at the open end and a point, a dot at the closed end. So this is the second particular wave, okay? So the A is the fundamental mode, B is the first overtone. So this first overtone, let's see what it gives us. So this lambda over 4, lambda over 4. So we'll have lambda over 4, 3 of them. So we'll have 3 lambdas over 4 for the length in this case for B. So lambda is 4L over 3. So the frequency for B becomes V over lambda becomes 3V over 4L. So if we do the same, this is 5 lambdas over 4 for the C. So you're going to have 5V. So you're going to have V3, 5, V over 4L. So it means the frequency will keep increasing in odd number whole numbers. So it's going to be 1, 3, 5 for V over 4L. So that's why the correct answer is this one. Okay, it's just a general standard case for. So if it's a pipe open at both ends, that behaves exactly like a string clamped at both ends, and that's going to be this first one. So that's when we have N equals 1, 2, 3, 4, and V over 2L. So for this one, we don't have even number harmonics for a pipe closed at one end. We only have odd numbered harmonics, first harmonic, third harmonic, fifth harmonic. But we have overtone. So the third harmonic is your first overtone. The fifth harmonic is your second overtone. So don't mix the overtones with the harmonics. But for a pipe open at both ends or string clamped at both ends, we have all the harmonics, first, second, third, like that. The first is usually called the fundamental. So okay, then the second is the first overtone. But there's no second in this case. The pipe will only have the third harmonic, which is the first overtone. The fifth harmonic is the second overtone. So if they give you a closed pipe problem and ask you to find the second harmonic, it's not possible. A pipe closed at one end, you can't. You only have first and third and fifth. Odd numbered harmonics are the only possible harmonics in this case. Thank you, and I'll see you next weekend. Have a good one.